Hello everybody. Today I'm going to show you how to set up the ISL28022 eval platform for the 8-site-in-1 platform, generic platform. And what you have here is 8 sites. One site here, and as you can see, these white little lines indicate each site. 1 site here, 2 site here, 3 site, down to 6, to the left to 8. This is where the microcontroller is, and this actually controls all 8 sites. There are banana jacks to interact for ease, interact with any external circuitry that you may want to connect to the power monitor. The SMA cable is used for an external clock. You can put a jumper here to connect the external clock and have all 8 sites sync, or port out a interrupt alert. Here are the VCC, which is a voltage coming from the computer, and a ground connector such that you can reference the board's ground to any peripheral circuitry. Now it's time to download the software. You navigate to Intersil's website and to the ISL28022 eval board software. Choose Documents and download the software under the ISL28022 DPM Multi-Site Software tab. Run the software. Now next, you're given a USB cable. You will take the USB cable and plug in, the cable into the ISL board. The 8-in-1 software has 8 ISL28022 chips. Each of them is 1 channel, so this would be Site 1, Site 2, Site 3, all the way down through Site 8. The ISL28022 has basic features. 1, the BRNG command, or the drop-down combo box, lets you select the range for the V-bus, 16 volts, 32, 60. The PGA lets you set the range for the shunt, 40 millivolts, 80 millivolts, all the way up to 300 millivolts for a range. The SADC is the acquisition time for the shunt measurement. The SADC time can range from 84 microseconds to 68 milliseconds. The SADC, or the shunt measurement time, and the bus measurement time can vary, or it can be separate. The BADC has the same selection feature. It can range from 84 microseconds for an acquisition time to 68 milliseconds. So on the first demonstration, I have connected on Site 1 the ISL28022 by using 2 sources. No resistive load, no nothing. So basically what you kind of see on the screen currently. I use 2 sources, and I'm just going to vary the voltage on each of the inputs. First, you want to connect the PC to the board itself via USB cable, and I'll press connect to device to have the software, the PC and the software connect together. And if you're successful, you'll see the device button change from connect to device to disconnect device in red, as you can see below. And you'll see an LED turn on the evaluation board. Currently, on the V-bus I put 12 volts. And on the shunt, I put 34 millivolts. The user can come over to channel 1. I set this up on channel 1 and press measure once. And once you press measure once, you can see it's 12.144. You can have the software scan through all 8 sites by pressing Start Data Collection. For every site that is totally on, it will collect data for. To shut a device off, you uncheck the V-bus and the V-shunt. And as you can see, the mode becomes 0. It turns to an off state. And it now will not poll that site. And you can do that for other sites as well. Now to change, as on channel 1, if you want to change the acquisition time for the SADC, we'll change it to 68. The slower the acquisition time, the more successive averagings, the more accurate the measurement will be. As you can see if I change the BADC from 532 to 84 microseconds, the acquisition rate will be faster, but the measurement will lose resolution. The ISL28022 has the ability to trigger an alert or an interrupt pin in case of any of the voltages, either the shunt or the bus, exceeds a set threshold. The alert feature button allows you to do this. A dialog box will come up, as you can see currently. No matter what range the bus and the shunt are at, the range of the alert features always stays the same. 0 to 60 volts for the bus and minus 0.3 to 0.3 for the shunt. All I'm going to do is I'm going to put 55 volts for a high threshold and 45 volts for a low threshold for the bus. What I'll do here is I'll put minus 0.045 to minus 0.03. So 45 millivolts and 30 millivolts for the high and low side for the shunt. There's also the option to just reset the chip, to a default state. You can do that in this dialog box as well by clicking the check over here. So press OK when you complete. Since we did 45 to 35, I'm going to measure once. Right now we're currently still at 12 volts for the V bus, so we're lower than our threshold rating. And as you can see here is that the backlight of the V bus is in violation, and it turns light blue, saying you're lower. For the shunt, it was between 30 millivolts and 45 millivolts, and that's within range of the thresholds that were set on the alert feature. So I'm going to start the data collection again, and as you see it's rolling. So I'm going to increase the bus voltage. As I increase the bus voltage, as you can see, it's getting 30 volts. Even what I'll do is I'll make a more accurate reading. There you go. Once you get above 45, you're back in yellow. Now, as you exceed 55, it turns an orange. And I similarly can do that with by setting the shunt voltage to make the backlights turn orange and blue, meaning that you're outside the range of the set thresholds. Reset 0.085 works. And as you can see, minus 0.085 is lower than your 45 millivolt threshold, and it turns blue. The next demonstration I'm going to give is showing the ISL28022 measuring current and power.